Greetings and welcome to my new calculus channel. My name is John Gabriel. So, in the last 5 videos, we saw 5 reasons in total of why your mainstream formulation of calculus is a load of bullshit. And excuse the fine language, but there's no other way to describe it. So, the 6th reason is that there is a solution to the problem, which actually doesn't only resolve the slope area problem since Newton and Leibniz's time, excuse me, but it also exposes the utter stupidity and ignorance of mainstream academics the last few 100 years. So if we write, oops, we can't do that. Let's get a thicker pen. So if we write f of x plus h minus f of x over h is equal to f of x plus q of xh. And by the way, you can't argue with this identity. It's true. Okay, it's a geometric identity, and it's true. So there's nothing you can say against this. And what it says, basically, again, to summarize, is that the left-hand side here is the slope of a non-parallel secant line. So if you have a curve like that, a tangent line like that, okay, then this left-hand side here, okay, is the slope of this line, okay. This f of x is the slope of the tangent line, okay, slope of this tangent line, and q of xh is the difference. So there's no arguing there. You can't turn around and say that's wrong because it comes from a theorem, and theorems are correct because they've been proved. All right, and I've proved this to you in previous videos. So there's no arguing that this solves the problem, okay, without the use of infinity, infinitesimals, or the circular rot of limits. But we're not finished yet, okay. Now, we know that all these expressions on the left and the right-hand side are constants, okay. So if you had to suddenly take limits of both sides, this particular term here is the one that stays constant in the mainstream, but somehow this term and this term change, okay? They change, right? Because this term here disappears and this magically morphs into the derivative, okay? So it's a whole lot of monkey business which mainstream academics themselves do not understand, all right? And they get horribly confused when they try to explain these things using epsilon delta arguments. And that's really what I want to talk about today. So there's this article on the web written by somebody called Yosin Lin. Okay, he was a student at Berkeley and he got a AA degree in mathematics, and then he did a major in electrical engineering, and then I guess he's just a teacher assistant from 1999 to the present. So maybe this hasn't been updated completely. But anyway, let's get rid of that. So Yosin basically got recognized for this article here. Further examples of epsilon delta proof. And it was written in 2001. So what one has to remember about Chinese students is that they tend to be very respectful, and I'm pretty sure that Lin knew more than his professor, but even though he tried to please his teachers and professors because he is respectful, he is still sincerely wrong. Okay, and it's a pity because he also fails to understand that what he has been taught is wrong to the very foundations. So he claims in his article that the limit as x approaches a of some function f of x is equal to L if for every number epsilon, assuming that there is such a thing as a real number, there is a corresponding number delta such that, well, there shouldn't be a such that the difference in x and a is less than delta will imply that the difference between f of x and the limit is less than epsilon. Okay, now this here it takes a slightly different form when we're dealing with a derivative because this function here is not a derivative. Okay, the form it takes is the one that you see down here. Okay, such that, oops, we've got that twice. I don't know why it's in there twice. So this is the form it takes. It's this difference quotient minus your guess, which happens to be the derivative somehow, which you get through the first principle method. So basically what you've got is this. Let's just clear this out. So you've got something like this. 0, oops, let's get a pen. You got 0 is less than x minus a is less than delta, and that implies that f of x minus a minus f of x over a minus L is less than epsilon. But this is very circular because, first of all, it means that you need to know L. But L is equal to the limit as x approaches a of f of x minus a minus f of x over a. Okay, it's equal to this limit. And this here in turn is what this inequality means. So it's circular, okay? So you start off with this inequality, which means this, and of course your guess is L, which you use in this. Okay, so it's just basically monkey business. Okay, neither Cauchy nor Weierstrass understood any of these things, and your mainstream professors don't. They're pretty confused most of the time. They can't answer your questions because they don't understand. So now, what are these arguments? So let's see what Lin says. And if he says that this is so, then an astute student will realize that there is not only one corresponding so-called number delta for a given epsilon, but a whole set of such delta. Okay, as I shall show you shortly with an applet. And this begs the question, why would delta even be significant if it is not unique? And there are many such deltas that would imply this right-hand side here. So Lin writes intuitively, okay, this means that for any given delta, one can find a delta such that this is less than epsilon. One of the problems with the word intuition is that it's usually unreliable. Now, I, who am a genius, never depend on my intuition, and it's generally better than anyone else's. Now, if I don't depend on it, and I may be incorrect, what does that say of everybody else? Okay, because intuition is the ability to understand something instinctively without the need for conscious reasoning. Read that a few times, stop the video and think about that. Okay, so Lin uses this word because his professors used it, and the morons before his professors used it. And it's being used in thousands of textbooks. Okay, it's a garbage word which shouldn't even be in the dictionary. So let me ask you a couple of questions. Can anything be understood with certainty without reasoning? Think about that. Anything. And is there even such a thing as unconscious reasoning? And if there were, would it be reliable? So the epsilon delta arguments depend on the basic idea that a subset. So let's go to my drawing board again. So what do the epsilon delta arguments depend on? So this is what it means. It means that if you have a limit, and supposedly you have it being have it been defined for some point A. Of course, in mainstream, they don't even care if it is defined at that point, but it has to be in the end somehow. They have to add that definition in. So they punch a hole here and they look at this region on either side of A, which is in the domain. Okay. And they say, okay, let's see, does everything in here map into a given epsilon? So if this is a distance of 1 from L and this is distance of 1 from L, does everything in here map into this region? So it's based on that idea. But it's flawed because what it tries to do is find the minimum of these deltas. As I'll show you, they don't all map into there. And they don't have a correct way of doing it because they've never understood limits, but I'll show you the correct way in a moment. Okay. So one still needs to know what the limit is. One cannot use the inequality without knowing L, but L is the limit, which is what needs to be proved. So clearly circular. And in the case of the derivative, you can't use f of x, but you have to use a finite difference. All right? So let's just go to this GeoGebra Outlet. So what we're seeing here is that, oh, and also the logicians, the bullshit logicians or non-mathematicians, have come up with an implies truth table that you see here, okay? That means not P or Q, okay? So if, for example, they've come up with a minimum, and the correct minimum is the one I show you, not the one that Lynn shows you. The one I show you is this one here. Delta is the minimum of the square root of 29 minus 5 over 2 and 5 minus square root of 21 over 2. Now, honestly, the best of you are too stupid to know how I got that. Okay, so I'm not going to dwell on that, but I'm going to show you. I'm going to show you that Lynn is wrong. It's not. It's not a minimum of 1 and epsilon over 6 as he claims in his article. He claims it's a minimum of 1 and epsilon over 6. That doesn't work because if epsilon is 1, then it's 1 over 6, which is approximately 0, comma 16, isn't it? All right, let's see. 6 inverse. So yeah, 0.1666. Let's just say to a few digits. Okay. So this is not true because there are deltas bigger than epsilon over 6. And here they are. Look, you can go all the way. You can go all the way up to 0.192192.582, okay? All the way up to this value that you see me pointing to down here, okay? And it's good up to that value, but if you try and go past that range, it will be incorrect, okay? And obviously, the result of this truth table is that it's false, okay? It doesn't imply the right-hand side. Of course, this truth table has nothing to do with the epsilon delta arguments, but it was inserted there because they needed more hand waving, more obfuscation, more stupidity, simply because they didn't understand, and they had to convince these students that there was nothing wrong with what they were explaining, but something wrong with the students' brains. It's actually the other way around. If you didn't understand the stuff, it means your brain is working correctly. Okay, that's what it means. Don't worry about the teacher's pet. Now, ironically, if you go to this little region, which is still the same, a certain amount of delta from the point, it's not true there because zero point 0.2 is greater than 0.192582. Okay, it's greater. So you have to be in the shaded region for this to be true. Okay, you see the result there is true, but if you go out of there, the result is false. Okay, you don't see true there. But inside here, it will be true. Step out, no longer true. Okay, see that? Okay, so, and also at this point of uh, the point where the limit is supposedly found, this inequality fails, and that's why you need a hole. You see, 0 cannot be greater than 0, and Uh, Also, 0 here for epsilon cannot be greater than 0 because epsilon must be greater than 0. So both delta and epsilon greater than 0 are greater than 0, and moronic mainstream academics make that happen by multiplying by x minus a over x minus a. So they forcibly punch a hole in the function here just so that this bullshit definition here is buttressed. Okay. So Lin makes a mistake in his calculation, clear mistake. He doesn't get it right. It's not the minimum of 1 and epsilon over 6. It's actually what I show you over here. Okay. Exactly, by the way. And you have more than one delta that will work. So, and some of you might say, well, the definition says that one of those deltas implies that. But there's nothing remarkable about that. You would expect that if you were looking at a region in which you're mapping values from the domain into the range. There's nothing remarkable about that. All right, so let's close this. And so what I'll do is I'll give you a link to this applet and summarize quickly. My historic geometric theorem exposes this fatal flaw. Okay, so you can't just decide that that goes to 0 and this left-hand side morphs into the derivative. It's just nonsense. I mean, it just shows you that your calculus teacher or your math professor is stupid. They don't understand these things. So I got a question from a student asking me, how is this definition significant? Well, my answer is in the green here. It's a testament to the utter failure, incompetence, and the grand stupidity of mainstream academics since Newton to realize a rigorous formulation of calculus. There's nothing rigorous about this definition here, which is the inequality that you see back here. Okay, that definition is this inequality, this MD thing here. Okay, which Cauchy proposed. That's what it is, and it's garbage. And of course, you can see when you look at the way mainstream academics try to explain, as you see over here, even this diagram is not necessarily correct because uh, the delta that you have on the left-hand side may not be the same as the delta on the right. Look here. See the shaded region here? For example, the distance from this point to this point here and this point here is the same. But if I had to take the delta on this side as 0.208, it wouldn't work. Look, if I had to try and go there, boom. All right, see, it's no longer true. You don't see a T there. You go back in there again, you'll see a T. See that? Okay, look. You're all morons. And this stuff is very complicated. And it's complicated for a reason. It's complicated because your prima donna professors of mathematics need job security. Okay. And they're basically placing you into debt for hundreds of thousands of euros or dollars and teaching you absolute nonsense. Now, in this article, one of the students made an interesting comment. You can read it here because I'll have a link to it. And so finally, I hope that you've understood why your mainstream formulation of calculus is a complete load of bullshit. Yes, the results are generally correct, but the formulation is a ton of crap. Okay, it's nonsense. It doesn't work, and I've given you a solution. I haven't just left you in your ignorance. I've given you the historic geometric theorem. That's this definition here. I've helped you. This is the definition. This has no limits, no infinity, none of that inequality BS that you find in your semester course on introductory calculus, okay? Or your basic analysis or your real analysis, whichever way you want to call it. If you're not a rare subscriber, become one. You can also join my members only channel for €5 a month. Okay. And you can click the join button to go there. I'm not going to do that right now. If you're not already a subscriber, become one. Click like, because I have many enemies in the mainstream. And they're constantly voting my videos down, by the way, because they need their jobs. And if I were in charge, they'd all be without jobs, because they're not mathematicians, A. B, they don't understand what they're teaching. They've never understood limits. I've never met one mainstream professor who has a clue what limits are about. And they're teaching this stuff, by the way. They're not teaching this stuff. They're peddling this drivel of theirs. So, also follow me on academia. And that's pretty much it. I hope you enjoyed this short series on 6 reasons why your mainstream derivative definition of calculus is flawed, and why you don't need any of the garbage that they teach you in mainstream academia. Okay. And none of this is rigorous for the 6 reasons I stated. I'm John Gabriel, and this is New Calculus Channel. Till next time, goodbye.